Okay. Good day, viewers all over the world. You're welcome to Toilet Online class. Today, I want to talk about set theory. So, we have introduced set theory and we have made some definition of terms. So, we'll be discussing Venn diagram today. That is the diagrammatic representation of sets. So, if you want to represent sets in a pictorial form, we make use of Venn diagram. Venn diagram. So how do we use Venn diagram to solve set problems? The first one is that you are to identify the sets, including the universal set. That is, if you want to use Venn diagram, you must identify what you are given, including the Venn diagram, including the universal set. Then we have to decide on the unknown, what is required, what we are required to find. Then the third one is that we draw a suitable Venn diagram. We're going to draw a suitable Venn diagram. Most often time when we have the universal, we represent the universal by a quadrilateral, probably square or rectangle. Then the subsets of that set it will be inside the Venn diagram. Probably we represent it by a circle. If there are three subsets, then you have something like this on the board. And if there are intersection between the two or more sets, there will be overlap as we have it on the board. Here, these are the where they have where they intersected. You understand? Then the third one is that we enter the data. The fourth point is that we enter the data. What we are given, we enter the data. Then finally, we now form an equation. We form an equation with the data for us to be able to solve the problem. For instance, if you have two sets A and B, if you have two sets A and B, so if you have to represent this in a Venn diagram, let's make some definition. Let's say A is equal to 1, 2, 3, 4, 5, and let's say B is equal to 2, 4, then let's say 6. So if you have to represent this in a Venn diagram, one thing you are going to check is that do they have something in common? Check the elements. Do they have elements that are common to the two sets? Yes. Then if you want to represent this, and let's say we have a universal set also in this case that starts from 1 to 10 to 10. Then if you want to represent the information in the Venn diagram, this is what we do. So we create a portion for A. So and if they are disjoint sets, that is they don't have anything in common, we are going to draw the two circles separately. But in this case now, they have something in common. Element 2 and 4 are common to both sets. So automatically there will be overlap. Then we now focus on A. A, we have element 2 here, we have 4 here. Then what do we have left in A? 1, 3, 5. In B, we have 2, 4, then 6. These have to represent this information. Then, you know, there are some other elements in the universal that are not in either A or B. So we write those ones outside 7, 8, 9, and probably 10. So these are represent this information in a Venn diagram. So when you have two or more elements, say A, B, and C. If you have two elements, A, B, and C. For instance, lesson number 1, you want to represent A intersection B. Provided that the elements are equal, then this is what you do. You say this is A and this is B. So the intersection will be where we have this overlap. That's what you're going to get. Okay. Then if you want to represent A union B, if you want to represent A union B, still the same thing. A union B, that will be A, set A, and set B, set A and set B. Union simply means intersection is and. Union simply means is that you have the element in A or B or both. So A union B will be everything here. You are going to shade everything that you have in both circles. That will be A union B. Then if you want to have A and A intersection of A prime, then This is what you have. When you have, let's say this is the universal, then this is set A. If this is set A prime will be what you have at the universal that are not in A. So you are going to shade outside. That will represent A prime. That is what we are going to have in A prime. Then you can also be asked to find A intersection B or prime. You know when we have intersection B, we only consider the overlap where both of them overlap. This is A and this is B. This is B. This is A. A intersection B is this point. It is here. But if you have to represent A intersection B, everything complements in the Venn diagram. Then this is what you have. Just consider A intersection B. Not shade everything outside A intersection B. That is the complement. Because as we have said, the complement of a set are the elements that you have in the universal that are not in that set. So in this case now, this is what you have. A intersection B or prime complement, that is A intersection B complement, will be all the elements that you have in A intersection B, all the elements that you have in the universal that are not in A intersection B. And if you have to represent it diagrammatically, this is what you are going to get. So if you have to find A union B, all complements, then it's almost the same thing. Just look for this is union of A and B. This is A, B, this is B, union of A and B. Then you shade everything outside. That would be the complement of A union B. Okay. So that is when you have two elements. What if we now have three elements? What if we have three elements? What are we going to do? If you have three elements, let's say A intersection B intersection C, still the same thing. Of course, the universal is in rectangular form. You represent the universal in rectangular form. Okay. Then there will be three subsets here. A, since it's intersection, all the three have something in common. B, then the third one, C, they have something in common. So the intersection of the three now will be the central here. That will be the intersection of the three. Because that is where all the three circles add their overlap. And that's what we are going to get. Then what if we are asked to shade, or we are asked to find A union B union C? If it's not intersection, we now decide to do union B union C, then you are going to clean this place. This is just the intersection. A union B union C. A union B union B union C will now be, you shade all the circles, all the three circles. Okay? You shade all the three circles. Then your shaded portion outside the three circles represents A union B union C, all complements. So that is what that will represent. So we are expected to be familiar with some of these, to be familiar with some of these concepts, because it's actually important for us to be familiar with some of these concepts. So I will want to give one or two examples under set theory notation. Now let's take example. Let's take example. 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 Let's say example one. Let's say example one. So the question says, in a class, in a class. So let's say example one. The question says, in a class, in a class of 36 students, in a class of 26 students, 29 do mathematics, 29 do mathematics, and 20 do chemistry. Okay, 29 do mathematics, 20 do chemistry. Full stop. So if five students do neither of the subjects, how how many students how many students do chemistry How many students do chemistry but not mathematics? Okay. So in this case now, we are given the total number. That's the cardinality of the universal is 36. The number that do that's the universal. Number that do mathematics is 29. The number that do chemistry is 20. 20. Then we also have number that do either mathematics, junior chemistry, all intersection. It is 5. That is 5 students did not do any. 5 students did not do any of these subjects. So the question now is that how many students do chemistry but not mathematics? How many students do chemistry but not mathematics? That is what we are about to find now. How many students do chemistry? So we want to find number of students that do chemistry. We want to find the number of students that do chemistry. Intersection mathematics prime. Let's call it S. That's what we want to find. So in this case now, let's represent the formation in the Venn diagram. Of course, there are 2 subjects here. Let's say this is the universal set. So let's this represent mathematics and this other one represents chemistry. Let's see represent chemistry. So let's X represent students that do both chemistry and mathematics. So 29 students do mathematics, that will be 29 minus X. Please let's note this circle, first circle from M, and this second circle is for C. In this case now, we are with the information we have that 29 students do mathematics. Out of the 29 students, it is possible to have students that do mathematics only, and some students will do mathematics and chemistry. But we don't know the actual number of students that do mathematics only. That is why we have to consider students that do that register for both. This is students that do mathematics, intersection chemistry, X. So also we have 20 students that do chemistry. So there will be some that do only mathematics alone. That will be 20 minus X. So 20 minus X represent the student that do chemistry alone. 29 minus X represent the student that do mathematics alone. Then X, student that do both. Then we are also given that 5 students did not do any of the 2 subjects. So that is intersection. Mathematics, junior chemistry, intersection. That is 5. We put this outside. Then the universal, the total is 36. So how do we now solve this problem? This is what we are going to do. If you follow the steps, the steps that I said, so this is what we are going to get. So we are going to add everything that we have inside this rectangle together and equate it to 36. And that's how to go about it. So here we are going to have 29 minus X plus 20 minus X plus 5 is equal to 36. So when we add everything that we have here together, it's going to give us the universal, the value of the universal. So this plus this is 49. So we have 54. Minus X, we take care of X. Minus X is equal to 36. So 54 minus 36 is equal to X. So X is equal to 18. So in this case now, it shows that 18 students do both chemistry and mathematics. But so that is, this is number of chemistry intersection mathematics, and it's X and it's 18. So 18 students do both chemistry and mathematics. So the question says that we should find the number of students that do chemistry. Is that the question? Students that do chemistry. How many students do chemistry but not mathematics? That is, we want to find the number of students that do chemistry intersection, not mathematics, but not mathematics. Then that will be 20 minus X, and that will be 20 minus 18. That is 2. So it simply means that only 2 students do chemistry. 2 students do chemistry, but not mathematics. So that is what we have. So 2 students do only chemistry, but they decide not to do mathematics, and nobody can force them. So we take another example. Let's take another example. Still under, we take another example. And that example is still under Venn diagram that has two, just two subsets. So in this case now, we are given that in the Venn diagram, in the Venn diagram, in the figure, in the figure below, in the Venn diagram in the figure below, the numbers, the numbers of elements, the numbers of elements are as follows, or are as shown. So what are the elements? So what are the elements? So we have this Venn diagram. So we can, as we can denote the universal like that. We have P. Here is P. Here is for subset P. Then we have this for subset Q. Okay. We have x minus 16. We have 4. We have x minus 11. Then we have x outside. That's the complement of, that is P union Q complement. We have that outside. So the question now says, given that the cardinality of P union Q, the number of P union Q is equal to number of P union Q complements, find x and hence find the number at the universal. Okay, this is what we are given. We are given this condition. So how do we interpret this condition? That is why it is compulsory, or it is necessary, to be able to represent that information in a Venn diagram. The number of P union Q simply means what you have inside P and Q. Okay, so that is when we have solution, when we have the cardinality of P union Q is everything you have inside P or Q or both. And it's the same thing as the cardinality of P union Q complement. P union Q complement simply means everything that you have outside, inside the box, but outside the two circles. That is the complement of P union Q. Then when we look at P union Q, what do we have there? We have x minus 16 plus 4 plus x minus 11. Everything being equal to what do we have outside P union Q is only x. It's x that we have. Then from there, I can clean the Venn diagram now, because we have seen, we have been able to generate what we have. So if that is the case, then we now have, when we had everything together, we have 2x. This is minus 25 plus minus 21 is equal to x. No, 16, no, 27. That's 23 equal to s. Then we have 2x minus x is equal to 23. So that x is equal to 23. So the first question, find x. We have gotten the value of x. Then the second one is that we define, this is the first question. We define x. Then the second question, we have to find the cardinality of the universal. So how do we get that? For us to be able to get that, we just add everything together. We are going to add everything that we have together. If we add everything together, we are going to have x plus, this is the first x outside, plus x minus 16. Just add everything together. Plus 4 plus x minus 11. So we add everything that we have together. This x becomes in. So we have 1, 2, 3. We have 3x minus 23. And we have gotten the value of s to be 23. So that will be 3 into bracket 23 minus 23. Then we have 69 minus 23. That is 46. So n of the value will be minus 26. And that is what we are expected to get. That's what we are expected to get. So I want us to take 1 or 2 examples in a situation whereby we have 3 subsets in a Venn diagram. So let's consider this. Let's consider this important example. Let's consider this example. So in this case now, Let's consider this example, say example 3 or 4. This example is when you have 3 subsets in a Venn diagram. The first example that we consider is when you have just 2. So in this case now, we have in a survey of 290 newspaper readers, 181 of them read the Daily Times. 142 read the Guardian. And 117 read the Punch. So let's underline what we are given in that question so that we'll be able to interpret it correctly. Read the Punch, and each reads at least one of the three papers, and each read at least one of the 3 papers. So if 75 reads daily, I want to abbreviate so that the question, we're not going to use a lot of space. If 75 reads Daily Times, let me abbreviate. Let me call Daily Times readers. Let me abbreviate it as D, Daily Times. Then let me use G for Guardian. Then let me use P for Punch. Okay, so that I'll be able to abbreviate it. I will write the question in mathematical form. So if 75 read Daily Times and Guardian, that is 75 read Daily Times and Guardian, okay, and 60 read Daily Times and Punch, and 54 read the Guardian and Punch. The first person now said we should draw a venn diagram to illustrate the information. That is, we are requested to draw a Venn diagram to illustrate the information. Then 2, how many readers read B Roman figure 1 now? All the 3 papers. Okay. B Roman figure 2, exactly 2 of the papers. Then Roman figure 3, exactly 1 of the papers. Then Roman figure 4, B Roman figure 4, the Guardian alone. So this is what we have. So in this question now, I want us to draw the Venn diagram somewhere. So let's first interpret the question, then we'll be able to draw the Venn diagram. What are we given? We are given the number of the universal as what? 290. That is the total number of readers is given as 290. Then out of the 290, 181 of them read Daily Times. We have denoted Daily Times as D. So we say the cardinality number that read Daily Times is equal to 181. Number that read Daily Times is equal to 181. Excuse me. Number that reads Daily Times is 181. Then number that reads Daily Times is 181. Then 141 read Guardian. Number of Guardian is equal to 142. The number that reads Punch is equal to 117. That's what we are given. We are also given that 75 read Daily Times and Guardian. Of course, we say number that read Daily Times intersection Guardian is 75, because intersection simply means and. The number that reads 75 reads Daily Times and Guardian. Then 60 read Daily Times and Punch. Number that read daily times intersection punch. Daily times that intersection punch is 60. The number that reads 54 reads guardian. Guardian intersection punch 54. And of course, we are going to have number that read all the three papers. Number that reads daily times intersection guardian intersection punch. We represent that as X. We represent it as X. So that's what we are going to get. So these are the available information. So these are the available information. So we just try as much as possible to be able to represent this information in a Venn diagram. So that is what we are going to have. We are going to we'll try as much as possible to represent all this information in a Venn diagram, and that is what we are. That's what we are. That is what we are about to do now. We want to represent all this information in a Venn diagram. So how do we do that? So we are going to sketch the diagram now. We are going to sketch the diagram. It's very simple and straightforward. Just concentrate and follow the steps. Just concentrate and follow the steps. So these are the informations that we are given. So how do we draw the Venn diagram? Please let's look up. Let's look. Let's look at the board. Okay. So in this case now, there are three. We have three different subsets of that universal. So we have something like this. So we are going to have about we are going to have three circles. This represents the universal. So let me represent this first information. The first one as the daily times reader D. So let's say these are the daily times reader D, and we have 181 of them. Then we have the guardian reader. There are 142. Then lastly we have the punch. Those that read punch P. There are 117. So from the information that we have the other time, we represented the readers that read all the three papers as X. So they are the one at the center, that is D intersection G intersection P is represented as X. So they'll be the one at the center. So we also know that 60 of the readers read daily times and punch. Daily times and punch 60. That will be 60 minus X. We are going to take care of those that read the three papers. We also know that guidance and punch, people readers that read guidance and punch are 54. So this will now be 54 minus X. The readers that read daily times and guardian is 75. So that will be 75 minus X, because we must take care of those that read the three papers. Now, how do we know the readers that read only daily times? Let's represent it as A. So we are going to find the value in form of X. How do we know those that read punch? Let's represent those that read punch and guardian. Let's represent that one as B. Then those that read punch, we represent this one as C. So how do we get the value of A, B, C in terms of X? This is what we are going to do. Just look at this is what we are going to do. This is what we are going to do. So if I consider the subset, this circle for daily times, I will add everything together in this circle. I will equate it to 181. Then once I do that, I'll be able to get the value of my A. So that is this is what I'm saying. I'll say A plus 60 minus X plus X plus 75 minus X. 60 minus X is equal to 181. Then I'll add everything in this subset together, equate it to 181 for me to be able to know the number of readers that read punch alone, which is denoted as A. So in this case now, minus X will take care of minus X. I will have 137 minus X A plus 137 minus X is equal to 181. Then let me make A the subset formula. A will now be 181. This 135 minus 135 minus 135 plus X. So A will now be 46 plus X. So the readers that read punch daily times alone will be 46 plus X. We must represent everything in form of X. We just have to represent everything in form of X. So I'll go to guardian. I'll go to guardian. I will add everything in this subset circle together where I have G. I will equate it to 142. Then I'm going to have 75 minus x plus 54 minus x plus b is equal to 142. The minus x can take care of x. If I add these two together, I'm going to get 129 minus x plus b is equal to 142. Then b will now be equal to 142 minus 129 plus x. Then b will now be 13 plus x. So the readers that read guardian alone in terms of x will now be 13 plus x. So this is how to represent your information in the Venn diagram. Then the last one is I want to find c. C represents the readers that read punch alone, only punch. Then how do I get the value? I will add everything together that I have in that cycle together, equate it to 170. That is, I will have 60 minus x plus 54 minus x plus c is equal to 117. So I'm going to have 114 minus x plus c equal to 117. Then c will now be 117 minus 114 plus x. Then c will now be 3 plus x. So the readers that read punch A only will be 3 plus x. So that will be 3 plus x. And that is a part of the question. This is what we are required to find. We have to represent the information in a Venn diagram. And that is what we have done successfully. So we now go to the B part of the question. The first question says that how many readers read all the 3 papers? So how do we know the readers that read all the 3 papers? This is what we are going to do. So in that case now, if you look at the steps that I gave us when I introduced the topic, the fifth one, it says that for us to be able to find the unknown, we equate everything that we have inside, everything that we have inside this rectangle, equate it to the universal. So in this case now, we are going to add everything that we have here now. Everything that we have here, we equate it to 290. So in this case, what we have now, we have 46 plus x plus 60 minus x plus 75. We have to be very careful here so that there won't be repetition or omission. Plus 13 plus x plus 54 minus x plus 3 plus x is equal to 290. So since we have plus minus, some of the x we cancel out, plus we cancel plus minus, then we are left with only one x. So let's add all these values together. This is 106, 181, 194, 98, 248. That's 251. We are going to have 251 plus x is equal to 290. Then x will now be equal to 290 minus 251. So x is equal to 39. So what is x? Number that read daily times intersection guardian intersection punch, as we have rightly stated, is equal to 39 students, readers. So in this case, the B, Roman figure 1, the B part of the question, B Roman figure 1, have been sorted out. That is 39 readers read all the 3 papers. That is what we are expected to do, and that's what we have done. So we have gotten the value of x, which is the readers that read all the 3 papers. So 39 readers read all the 3 papers. So we move to the second question, B Roman figure 2, where we are asked to find the numbers that read exactly 2 of the papers. Now let's look at readers that read exactly 2 of the papers. These are the reader 1, 2, 3. That is where we have 60 minus x, read daily types and punch, plus 75 minus x, read daily types and guardian, then plus 54 minus x. Those are the readers that read punch and guardians. So we know the value of x now. We now say 60 minus 39 into plus 75 minus 39, then plus 54 minus 39. So this will give me 21 plus this is 36 plus 39, 15. So if we add everything together, here we are going to have 15. We are going to have 72. So it shows that 72 readers read exactly 2 of the papers. Then B Roman figure 3, we are asked to find the readers that read exactly 1 of the papers. So how do we know readers that read exactly 1 of the papers? This is A, B, C. That is A. That we represent readers that read only daily times as A, only guardian as B, then only punch as C. So readers that read exactly one of the papers will now be A plus B plus C, which is equal to 46 plus X, representing A, plus 13 plus X, that represents B, then 3 plus X, that is for C. So we are going to have 46 plus 39 plus 13 plus 39, then plus 3 plus 39. So this gives 5, that's 85, plus 59, that's 52, plus 42, that's 94. Then at the end of the day, we are going to have 179 readers. So 179 readers read exactly one of the papers. Then the last but not the least, Roman figure 4, B Roman figure 4. We have to find the readers that read guardian only. Guardian only. So if you look at the diagram, readers number that read guardian only is B, is denoted as B. Then what is B? 13 plus X. That is same thing as 13 plus 39. Then that will be 52. So 52 readers reads guardian only. So 52 readers read guardian only. And that is what we are asked to find. So I'm going to take, so you can just go through, just try and get good textbooks so that I'll be able to read further examples on this. So let me just give us the sets, the law of set of algebra. Law of set algebra under sets, then we'll close for the day. So the laws of algebra, of sets. Okay. So when I introduced Venn diagram, so we realized that Venn diagram provides a method for showing certain basic results in algebra of sets. The first one that we are going to talk about is the commutative law. In the commutative law, we are able to show that with the aid of Venn diagram, we know that A intersection B is same thing as B intersection A. Not only that, A union B will also be same thing as B union A. So with the aid of Venn diagram, we can actually show this. That's the first one. Then the second one is associative law. In case of associative law now, we have three elements. That is, we can have A intersection, then B intersection C. That is, if you first find B intersection C and relate it with A, it's the same thing as you saying A intersection B. You first look for this value and it relate it with C. And the other one is when you have A union B union C. So this same thing as saying A union B, then thereafter you consider it with C. You are going to get the same thing. So the first law is the commutative law. The second one is the associative law. Then we move to the third law. The third law is the distributive. 3. We have the distributive law. Distributive law. So we have the distributive law. In this case now, when we have A intersection B union C, will it be the same thing as A intersection B, then everything union A intersection C? That is what you have. That is, in this case now, we want to show the distributive law shows that intersection distributes over addition. Or if we have A union then B intersection C, will this be the same thing as A union B, then intersection A union C? So that is distributive law. Then the fourth law of algebra of sets is what is called the laws of set absorption. So in this case now, law of set absorption, A, where we have A intersection then A union B. is equal to A. That is, if you find two sets A and B, the union of two sets A and B, when you relate it with A and you relate it with the intersection of A, automatically we must get A, because intersection simply means addition, simply means and. Then if you have A union, then A intersection B. Also, in this case, we are going to get A, because A intersection B automatically will be A. Then A union A is going to give us, that's what we are going to get. Then the fifth law is called the idempotent law. Idempotent laws. Then this simply means that when we have A intersection A, is same thing as A. Then when we have A union A, is same thing as A. That is that about idempotent law. Then the sixth law is very common at the elementary stage when we are talking about set algebra. The sixth law is called the De Morgan's law. Almost everybody have heard about this. De Morgan's law. So in the case of De Morgan's law, it says that when we have A intersection B prime, is same thing as A prime union B prime. Of course, you can check out all these law of set algebra. You can actually verify them. Then it says that when you have A union B, everything prime, is same thing as A prime intersection B prime. So that's what the law says. That's what the De Morgan's law says. Then the seventh law, all these laws are verifiable. It's something you can verify. It's called the law of complementation. It's called the law of complementation. The first one is when you have A intersection A prime, it's going to give us empty. And of course, A, if you have subset universal, A is the subset of universal. And A prime are the elements that we have in the universal that are not in A. Once you take the intersection, we are going to have an empty set. Then if you have A union A prime, that's going to give us the universal. So all this law of sets, law of algebra of sets are verifiable. Then if you have the universal complement, of course, it's going to be empty. Then the last one is when you have the empty complements, you are going to have universal. So this is law of complementation. Then the last law that we are going to talk about is the laws of inclusion. That is, this is the last law, laws of inclusion. Laws of inclusion. The first one, it says that if A is a subset of B and B is a subset of C, then A is a subset of C. So if A is a subset of B and B is a subset of C, automatically A will be a subset of C. Then the second one says that if A is a subset of B and A is a subset of C, then A is a subset of B intersection C. Okay? If A is a subset of B and same A is a subset of C, it simply means that A is a subset of B intersection C. Then the third one there says that if A is a subset of B, then A is a subset of B intersection C for any set C. So that is the last laws of algebra of sets that we are going to consider. So all these 8 laws are verifiable. It's something you can verify. You can just use simple examples. Just give a set. Just say something like A. Define A as maybe even number from 1 to 10, 2, 4, 6, 8 to 10. Then say B is equal to maybe odd number up to 6, 1, 2, 3, 4, 5. Then include 6 and probably 8. Then let the universal, we can represent the universal to be number from 1, 2 up to 10. So if you use this, and then it still can be any set. If you use these 3, you can verify all these the laws of algebra of sets. So I would love to stop the class now. So if you have further examples, further question under set theory, either the introduction or Venn diagram, just make your request in the comment section. I promise to attend to it. Thank you for listening. Kí ló ṣe kíni? Ẹ ṣẹ́